Welcome to the Unit 2 Test Remediation Guided Practice for Unit 2 in Pre-AP Chemistry, or excuse me, in Honors Chemistry. The first thing that we want to do is we want to look at some terms here. So we want to define the following terms, and the first thing that we have is we have intensive properties and extensive properties, and they're very similar to one another. But remember, an intensive property is something that does not depend on amount. Okay, so it's things like color, taste, those sorts of things that do not change regardless of how much material is there. So they do not change. The other ones that you have are extensive properties. Extensive properties do change based on how much material is there. So you can think of it like adding sugar to Kool-Aid. The sweetness taste does depend on how much sugar is there, but the taste of sugar itself does not depend on whether you have 5 grams of sugar or 20 grams of sugar. So they do change based on amounts. Okay, remember, you can refer to these definitions when it says circle all the terms for intensive properties. So the one that we're going to look at here is we're going to look at conductivity. Conductivity is the ability to conduct electricity. So for example, if you have a glass of tap water or salt water, we'll call it salt water. If you were to put in an electrode here and an electrode here, you can actually light a light bulb up. Whenever you light up the light bulb, it does not depend on whether the salt water is here or here or here, as long as those electrodes are going into the salt water. So since it does not depend on the amount of water that's present, you can say that conductivity is an intensive property because it doesn't depend on how much. So what you should end up being able to do is you should be able to say that the intensive properties are those. Finally, when you look at this last one, you should be able to say that for this particular example, you were talking about an intensive property, an extensive property, you're talking about an intensive property, you're talking about an extensive property, and you're talking about the total number, so you're talking about an extensive property. And if you don't understand those or you're not quite sure where you're going from there, make sure you seek help from your teacher. The next one it says is to write the density equation and solve for each variable. So the first thing we're going to do is we write the density equation, which is density is mass over volume, and we want to solve for each other variable. So the first thing I can do is I can solve for mass, and how I'd do that is I'd multiply both sides by volume, so I'd end up getting density times volume. The final one that you have is you would say volume equals mass over density. If an object has a mass of 15 grams and has a density of 2.3, what is the volume of the object? So since I'm trying to solve for volume, what I would do is I could use this one directly, or you can plug in your variables into the density equals mass over volume. What you would notice is that mass goes here, density goes here, and when you solve for volume, you know that you're going to solve for volume and the units are going to be in milliliters. If you do this correctly, you should end up with a density of about 6.5, or excuse me, a volume of about 6.5 milliliters. Okay, next you have an unknown gold colored. Now just because it's gold colored doesn't mean it's gold, and it gives you the mass and it gives you the volume. It says pure gold has a density of 19.3. You should be able to figure out that no, it's not gold, or at least not pure gold. It could be gold on the outside. Oops. So next, we want to look at the states of matter. What are the states of matter that are covered in this class? The first one we have is solid, and solids are particles that are closely packed together. Then you have liquids, and then you have gases, and those are things that you are generally familiar with. And outside of gases, you actually have plasma as well. And all plasmas are superheated gases that actually lose their electrons. So next we have what is the state of matter is not compressible and has an undefined shape. So the first thing we want to look at is we want to look at what are the two states of matter that are not compressible. So if you look, if you were to try and squeeze a solid object like your desk or a book, if you were to try and squeeze it on all sides, or a cement block, it won't compress. It may eventually fracture or break or something along those lines, but it's not going to compress. It's not going to get any smaller. And actually, water is the same way. Like all other liquids. If you try and squeeze water, it just changes the shape. It doesn't actually squeeze the volume of water. So these are the two ones that are not compressible. So now you have to say which one of these has an undefined shape, and you should be able to say that it is a liquid. Finally, it says you should be able to figure out the last one is that it's going from a gas to a liquid to a solid, and you should be able to justify that. Okay, next it says draw a flow chart for all matter using the terms elements, compounds, homogeneous and heterogeneous mixtures. So the first thing that we want to do is we want to start out and we want to divide, is it an element or is it a compound? Or is it multiple elements? So we ask ourselves, does it have one or more substances? Not substances, elements. Well, elements isn't a great term. Yeah, I guess we'll use the one or more element. That's really all we can say at this point. So does it have one or more thing on the periodic table? If yes, congratulations, it is an element. If no, then you have to ask yourself another question to figure out. You have to say, are all elements bonded, which means connected? If the answer is yes, then what you have is a compound. If the answer is no, you have to ask yourself one more question. You have to say, is the sample the same everywhere? If yes, then it's homogeneous. If it's no, it's heterogeneous. So now it says label the following elements, compounds, homogeneous and heterogeneous mixtures. So I look at salt and it says NaCl. So I say, does it have one or more element? Oh, excuse me, I messed this up from the very beginning. It should be no and this should be yes. It really threw me off there. So I say, does it have one or more elements? Yes. Are all the elements bonded or connected? Yes. Na is connected to Cl. So because of that, I know that this is a compound. So now I look at distilled water. I say, is there one or more element? Well, water is H2O. Okay, so yes. Are all the elements chemically bonded? Yes, H2O. And there's nothing else in it, so I would say distilled water is also a compound. So this is what you do is you go through all of these things. You make elements, compounds, homogeneous and heterogeneous mixtures. Next, it says list 3 substances that are elements, compounds, homogeneous mixtures, those sorts of things. So the first thing you would do is just name a couple of elements. So elements are anything on the periodic table like gold or silver or copper or anything along those lines. Compounds are anything that has multiple atoms like CO2, H2O, O2, H2, any of those things that has more than one element present. A homogeneous mixture is going to be something along the lines of it's the same everywhere. So the one I like to give is generally milk, because milk, when you take a sample at the bottom and the top, is going to be the same. And a heterogeneous mixture I like to say like orange juice, because orange juice tends to settle, or you have pulp at the bottom and you have water at the top. Next, we need to define the following terms. You have a physical property, you have a physical change, you have a chemical property, and you have a chemical change. Now, the biggest thing that you can differentiate between physical property and chemical property is this is a property by itself. And chemical property is how does it react with others. Okay, so how does it react with others? So an example of a chemical property would be combustibility. Can you set it on fire? So in other words, how does it react with oxygen? Whenever you have a physical property, you'd be like, oh, it's red, or its pH is 2. It's something that can be measured independently. A physical change is something in which you have the same substance, just rearranged. An example of a physical change would be boiling or melting. You know what? You still have water when you boil or melt something. You haven't converted it into hydrogen and oxygen gas. Okay, whenever you melt ice, it's not something new. It's just water that's in a different shape. Okay, a chemical change is where you no longer have the same substance. Like when you start off with octane, octane is this in your gas tank. It reacts with oxygen and it becomes something completely different. It becomes carbon dioxide and water. These are two totally separate things than what I had before. So that's combustion, which is what you have, is a chemical change. Okay, so describe these as chemical or physical changes. You should be able to look through these and say, oh wow, burning wood, that's clearly a chemical change. Breaking glass, it's still glass, so it's physical. Boiling's physical. You should be able to say physical, and then you should be able to do the next two. Okay, the next one, you should be able to take a look at this right here, and you should be able to identify that there are physical change or physical properties that are being looked at here. You have a chemical property that's being looked at here, and a physical property that's being looked at here. Finally, we need to look at kinetic molecular theory. And kinetic molecular theory has to do with gases. So the first thing we're going to do is we're going to apply and just say, hey, it has to do with gas. And we want to talk about the postulates of it. We want to say, number one, atoms are small. And that seems ridiculous, but really what it means is atoms are small compared to the volume that's here. So what you have here is you have a molecule there and a molecule here, and the diameter of this atom is very small compared to the distance in between them. So atoms are small. There are no IMFs. An IMF stands for an intermolecular force. In other words, this atom right here is not attracted or repelled from that atom in any way, shape, or form. So there's no attraction, there's no repulsion. So there's nothing going on there. Okay, next, it's that the temperature is proportional to the kinetic energy. So in other words, when you increase the temperature, the molecules themselves move fast. Okay, next you have the fact that the atoms move in straight line motion according to Newton's laws. And finally you have collisions are elastic, which means they bounce. So molecules bounce off one another, elastic. Okay,